Okay, hi, we're pen pal 2000. So initially we tried to follow the instructions and run the PHP my admin server, as mentioned in the lab 3 instructions, but like other students, we encountered significant difficulties in the installation process. So we have tried for a couple of hours, like multiple attempts like installation and tweaking the configuration file, but it wasn't like working properly and the interface window did not load. And we've confirmed that both MySQL and Apache 2 services were running as they should be. So we have collectively decided to explore alternative tools for the data store and management. We thought about using Microsoft SQL Server and SQL Workbench, but we've decided that SQLite 3 was the best alternative. Um, some of the reasons why is, first of all, its simplicity. SQLite is known for like the ease of setup and use. It doesn't require a separate server process. So we thought it would be like a great lightweight database solution. The second reason is portability. Portability. SQLite 3, it has like it's set up in a way that like the entire database is stored in a single file. So it's really easy to move it between like our different machines and environments. And because we're collaborating together, we thought um, it would be great to use. And especially when we further analyze stock data, it would be useful to have data presented in such an easy and straightforward format. The third reason is low resource requirements. So SQLite 3 is a resource efficient, and we thought it would be perfect for the application that's run with minimal system resources. And the last one is reliability. SQLite 3 is like reliable and robust and self-contained and serverless. So we thought it would reduce the risk of configuration errors for our project. So following our decision, we've successfully installed SQLite 3 and created two tables within the SCI 560 Lab 3 database. And this was a key milestone for our project. It allowed us to move forward with the new phases of like data collection, pre-processing, and analysis. And
Oh,
now that's what we'll talk about the further things.
all right. So I'll just quickly go through uh the SQLite database we're using. Um, so I'll go to my database for this lab, which is DSCI 560 Lab 3. And in here I've created two tables, the portfolios and stocks. Stocks processed are for data preprocessing code that Yuko created, and he'll talk about it later. So here I've pre created two table schemas. One is portfolios, one is stocks for when we later fetch the data using YFinance package. We'll fill the data in here in these two tables. And I'll go over the stock fetching code. So here, the stock fetching code basically fetches stock data from this set of stocks that we selected. These stocks coming from four different industries. They're entertainment, technology, financial industry, and also manufacturing. So this two lines allows us to connect our Python script to our SQLite 3 database. And here we used YFinance to actually fetch the data. And also here, because we're only interested in the real-time data, so every time we run this code, it will just replace the format data stored in the stocks table in our SQLite database. So it will also give user the most like real-time data. So if we ran this, uh, Wait. Why is it not running? Oh, okay. So there are three stock symbols that are currently like delisted. I guess Facebook already changed to like Meta. So out of the 40 companies that were interested, there's three stock symbol that are delisted right now. But we can still go to the SQLite3. So we can use SQL query to access the data in stocks table. So these are the real-time stock data that we fetched using YFinance package. And we'll also go over the portfolio management portion of the lab3 that is handled by this script. So there's six options for a user when the script runs. So the first one is for users to create a new portfolio. So we can do that, just one, and we can have a name for the portfolio. We'll just go with USC 101, and it will auto generated an ID for that portfolio, which is 3 because we've already generated 2 portfolios for testing purpose. And after that, you can add a stock to this portfolio. For example, you just choose option 2 and enter your portfolio ID. Enter stock symbol. We'll just go with RTX. Okay, so it displayed that stock RTX are successfully added to portfolio 3. You can also remove it. I just won't be displaying this function right now. And we can also display all portfolios. As you can see, we have portfolio ID1, ID2, ID3 with different names and different stocks in them. User can also like fetch stock data for a specific portfolio. We'll just do that for portfolio 2. So we first choose 5, enter your portfolio ID, and we'll just go with 3 days. So it will display the fetch data for stocks for the stock in the specific portfolio that you want to fetch data from. And the last option is just exit. And I'll pass it to Yuko. We'll go over the data preprocessing part.
Yeah. So if you can open the data preprocessing file, right. So for the data preprocessing part, our task was to handle the missing values from the stocks table, as well as transforming the data so that it's in a suitable format for analysis for part 2. So the first thing I did was get data. So I'm connecting to the database that Kylon created, and then selecting the stocks table and fetching all the data. And then I'm converting the data into a pandas data frame. And for convenience, I'm changing the date column into a date time, a pandas date time. And then the second function is filling the missing values. So first it will try a forward fill for all the empty cells. And if that doesn't work, then it would try the backfill. And in the next function, the next function is the add difference. So Here I am taking the difference between the high price and the low price. And in a sense, that is kind of like the volatility of the stock. So at the peak of the day and at the lowest of the day, how much difference there is. And also I'm taking the difference between open price and close price, which is just the difference between the first price of that day and the last price of that day. The last function is output to SQL. So I output the pandas data frame into an SQL format and storing it into the database as a new table called stocks-processed. So if you go back and go to SQLite 3 and open the database, and go into .schema, we can see that the stocks processed table is successfully created. And if you look into the table using select star from stocks processed, we can see that the date has been turned into date time, and then 2 extra columns have been created. And that's it.